Good afternoon, everyone. Today we will start the linear algebra part, Chapter 1, Matrices and the System of Equations. And we were looking at the system of linear equations in the matrix format for the Chapter 1. Now, Section 1 is about the system of linear equations. First, let's look at the linear equation. What is the linear equation? A linear equation in n unknowns is an equation of the form like this. a1x1 plus a2x2 plus anxn equals b. So here we have n variables, right? Or we call n unknowns, x1, x2 until xn. And then all the A we called AI, right? All the A1, A2 until AN, and the right side constant B, okay, B are called the real numbers. They are real numbers. It's a linear function for each variable, x1, x2 until xn, which means we don't have any term x1 square, right? The degree is greater than 1. So from here, we can recall the linear function, okay? The linear function about one variable. That is y equals mx plus b. And also we can take this one as the polynomial of the variable x with degree 1, right? With degree 1. So it's called a linear function. So here it's a linear equation, which means for all the variables, it's linear. The degree is 1, okay? Degree is 1. So that is one linear equation, okay? One linear equation with n variables, okay? With n variables. Now, let's looking at what is the linear system, okay? A linear system. A linear system of m equations in n unknowns is then a system of form. Let me write the form, okay? Let me write the form, which means we are going to have m linear equations together, okay? So the first one will be a11x1 plus a12x2 plus a13x3 until a1nxn equals b1. That is the first linear equation, and we have two digits for the real numbers a, okay, and b1. Then the second equation will be a21x1 plus a22x2 plus a2nxn equals b2. And if we have the case equation, that will be ak1x1 plus ak2x2 plus aknxn equals bk. And then we do have am equation. So the last equation will be am1x1 plus am2x2 plus amnxn equals bn. So be careful of the subscript for all those aij's, okay? All those aij's. So you will notice that we have two-digit subscript, two-digit number of subscript for the a, right? For the a. So the first one denotes in which equation. So for the first equation, the first digit are all ones, right? You will notice that. And for the second equation, the first digit of the subscript for A is A21, A22 until A2n. In the case row, in the case equation, that will be AK1 plus AK2, x2 plus AKN. And then in the last M equation will be AM1, AM2 until AMN. Right? The first digit is M. And then how can we decide the second digit number of the A? So that is the same subscript with the variable xj, right? Xj. So A11 x1, A12 x2. The second digit number is the same as the variables. Okay, is the same as variables. But B, the right side constant B, sorry, here should be Bm. Okay, Bm. We have M equations. So the subscript for the right constant B is the same as the first digit subscript with I. So here x1, x2, xn, they are called n variables or n unknowns, right? N variables or n unknowns. And here Aij, okay, Aij and Bi, right? Aij and Bi, they are real numbers, right? They are real numbers. Real numbers. Try to take note of this linear system. This is the standard format. Okay, this is the standard format when we recall a m by n linear system. It's called m by n linear system. Okay, so the number of equations is m by n linear system, which means we do have m equations with n variables, okay, with n variables. And it's all the n variables come through with all those m equations. It's the same n variables, right? Of course, the purpose when we discuss this linear system is try to solve this one, but be patient. Be patient. We will go through the whole chapter to discuss the solution of this linear system. So please take note of this linear system. Okay, it's a standard format of the m by n linear systems. Now let's check some simple one. Okay, let's check some simple ones. So part A. What is this system called? What are m and n? What are the values for m and n? How many equations do we have for part A? Those are also the linear systems, right? So part A, we do have two equations, right? Two equations. How many variables? We only have two, x1, x2, right? So two variables. N is also two. So this is called a 2 by 2 system. Okay, for sure, we can just call it system. And then how about B? How about part B? How many equations do we have? How many variables do we have? Two equations, of course, right? How many variables? Three. So this is called 2 by 3 system, right? 2 by 3 system. And then part C. What are the values for m and n? How many equations do we have? Three, of course, right? We do have three equations in part C. Be careful. And how many variables? Two variables. So this one is called 3 by 2 system. Okay, 3 by 2 system. But we should be careful. Okay, we should be careful of all those systems. Now, let me show you. Okay, let me show you part A. Okay, for part A, let's talk about part B. Okay, part A is much easier. So we know part B is 2 by 3 linear system. If we recall the standard format for 2 by 3, which means we have two equations. We have A11x1 plus A12x2 plus A13x3 equals B1, right? Equals B1. And then A21x1 plus A22x2 plus A23x3 equals B2, right? Equals B2. So that is the standard 2 by 3 linear system for this one gives the standard one. Now comparing with this standard format, let me ask what is A11? So what is A11 for part B for this specific system? What is A11 in part B? So in part B, you can take x1 as 1 times x1, right? So of course, A11 is 1. Make sense? A11 is the coefficient actually, right? We can call those Aij a coefficient, okay? Coefficient. How about A12? Is A12 1 or minus 1? A11 x1 plus A12 times x2. So you can take here as plus minus 1 times x2. So A12 is minus 1, right? A12 is minus 1. How about A13? How about A13? A13 is 1, right? Again, it's 1. How about B1? How about B1? Of course, B1 is 2, right? The right side constant, 2. And then A21, A21, A21 is 2, right? Just comparing with the standard format. A21 is 2. How about A22? A22 is 1. How about A23? A23 minus 1. B2 equals 4, right? B2 equals 4. So comparing with the standard format of 2 by 3 system, we can figure out all those real numbers. Aij are usually we call the coefficient, okay? Coefficient of the linear systems. And the BI's are called the constant, right side constant. We know they are all real numbers, okay? So that is part B. Now let's check part C. Part C is called 3 by 2 system. If we recall 3 by 2 system, okay, 3 by 2 system, that will be A11x1 plus A12x2. We do have two variables equals B1. And then A21x1 plus A13. Do we have A13? It's 3 by 2 system. Do we have A13 here for part C? Part C, 3 by 2, which means we have 3 equations. We don't have x3. We only have 2 variables. Why should we write A13? That's why the system are different, right? Depends on the m by n. Depends on the values for m by n. So here A22x2 equals B2. A31x1 plus A32x2 equals B3. That is the 3 by 2 linear system in the standard format, right? So here, what is A11 for part C? What is A11? 1, right? A12, 1. B1 is 2, right? B2, 1, right? B2, 1. B3, 4. Now let's go through all the Aij's. A11 is 1. A12, 1. A21, 1. How about A22? How about A22? A22 is minus 2, right? Minus 1, right? A22 is minus 1. How about A31? A31 is 1. How about A32? How about A32? Here you can take the third equation as 1 times x1 plus 0 times x2, right? We do have the variable x2, but the coefficient A32 is 0 especially, okay? So for part C here, we take the A32 as 0, okay? It's not exist, okay? It existed. It existed. The coefficient A32 existed, but equal to 0, okay? Equal to 0. So we can figure out if we're giving a simple linear system, we can figure out all the coefficient Aij and Bi's, right? And we know the m and n values. M denotes the number of equations. N denotes the number of variables, right? Now let's start from the 2 by 2 systems, okay? Let's start from the 2 by 2 systems. Let us examine geometrically a system of these 2 by 2. We have two equations, okay? Two equations with two variables. So 2 by 2 system we can write in this way. A11x1 plus A12x2 equals B1. A21x1 plus A22x2 equals B2, right? And we can check those two equations in a geometric way to draw it. Now I'm going to use some other notations, okay? So I will let x equals x1 and y equals x2. I'm going to write it in this way, okay? I'm going to write it in this way. So for the first equation, okay? For the first equation, I'm going to rewrite those two equations, okay? So equation 1, that becomes A11x plus A12y equals B1. I just use a different letter, okay? Different letter. Then equation 2, I can write A21x plus A22y equals B2 in this way, right? So I'm going to express my y, okay? I'm going to express my y. So I will rewrite in this way. Then A12y equals B1 minus A11x. No problem, right? So I can express my y in this way, divided by A12. So that is minus A11 over A12x plus B1 over A12, right? Everyone is clear? So we express y. We express y using x. So that becomes minus A11 over A12 times x plus B1 over A12. Actually, Aij and Bi's, they are all real numbers, right? They are all real numbers. So here, this one, minus A11 over A12, that is the number. B1 over A12, it's also a number. So if we check the linear equation, okay? If we check the linear equation or linear function, okay? The linear function, y equals mx plus b, right? If we check in this way, what is my slope? So here the slope is minus A11 over A12. What is the intersection? What is b? B equals B1 over A12. So that means between x1 and x2. Here x means x1, y means x2, right? It's a straight line. Everyone is clear? So that means it's a straight line. So this one, if we express in this way, that means this part is the slope, mx plus b. So actually this is the straight line with the slope this one and the intercept this one. So here actually this gives a straight line, okay? Straight line. So that is the first equation, okay? That is the first equation. If we check the second equation, okay? If we check the second equation and we express y using x, a22y equals b2 minus a21x, and then express my y is minus a21 over a22 x plus b2 over a22. It's also a straight line, right? It's also a straight line. What are the slope and intercept? The slope is minus a21 over a22, and the intercept is b2 over a22. Of course, here we will assume a12 not equal to 0 and a22 not equal to 0, right? Not equal to 0. And by the way, what happens if those two equal to 0? Let's think about it. If a12 equal to 0, that means a11x1 equals b1. So that means x1 equals b1 over a11, right? So that is just the vertical line. x1 equals, so we take x1 as x, so it's a horizontal line. And if a22 equal to 0, that is the same. x1 equals b2 over a21. It's just a vertical line, okay? Vertical line. x1 equals those values, equals a value that gives a vertical line. So generally when a12, a22 are not equal to 0, we can express y. We can take my x2 as a y-axis, so we can represent it as a straight line. How can we form the straight line? You can take your x1 as the horizontal axis. x1, O, x2. That is what I said here. We let x equals x1, y equals x2. Okay, so your x1 is the horizontal axis, x2 represents the vertical axis. So those two equations, if we rewrite it, if we express x2 using x1, that means two straight line actually, right? That means two straight line. And how about we solve those? So here, each equation can be represented graphically as a line in the plane, right? As a straight line. Of course, generally they are two different straight lines, okay? They might intersect, okay? They might intersect with each other or not, okay? So generally there are two straight lines in these x1 or x2 planes. Everyone is clear? So if we establish the coordinate in this way, then equation 1, equation 2, they represent a straight line in these coordinate systems. So that is 2 by 2 system. And let's look at specific example to understand two straight line, okay? Two straight line. And of course, a 2 by 2 system, we can recall that a11x1 plus a12, okay? a12, be careful, it's not a21 equals b1. a21 means the second equation. a21 goes to the second equation, and then plus a22x2 equals b2. Now let's check those three 2x2 system. The first one, as I said, we can let x2 as y, okay? We can let x2 as y. So we can rewrite both equation, okay? Both equation. So equation number one, x2 equals minus x1 plus 2, right? And equation 2, x2 equals x1 minus 2, right? If we express x2 as a y, so we can rewrite those two equations in this way. x2 equals minus x1 plus 2. x2 equals x1 minus x2. Now, let's draw those two straight lines. It's easy, right? Those are, of course, two straight lines. Slope, what are the slope for the first one? Minus 1. Intercept, 2. Second straight line, slope is 1. Intercept is minus 2. So x1, O, x2 coordinate. Let's draw the first straight line. Minus, so that will be y equals minus x, shift 2 unit upward, right? Shift 2 unit upward. Here is 2, here is 2. So this is x2 equals minus x1 plus 2. And then, how about the second straight line? Second straight line is x1 minus 2. So will be y equals x, shift 2 unit to the right. Shift 2 unit to the right. So this blue line is, sorry, x2. x2 equals x1 minus 2, right? And you will notice that actually there is a intersection of those two straight lines. They intersect at this point. What is this point? What is the coordinate for this point? The coordinate is when x value is 2, y value, x2 value is 0, right? So let's check that, okay? Let's check that. So when x1 equals 2, let me write there. So from the graph, we will notice that those two straight lines intersect at the point when x1 equals 2, when x2 equal to 0, right? Intersection means that satisfy those two straight lines, right? Here, when x1 is 2, of course x2 is 0. This red straight line. And this blue one, when x1 is 2, of course x2 is 0, right? So here, this one is the intersection, no problem, right? This is the intersection of the straight line. Let me write in the purple color. That is the intersection of two straight lines. 2, 0, right? 2, 0. And if you check when x1 equal 2, when x2 equals 0, 2 plus 0 equals 2. 2 minus 0 equals 2. So that is actually the solution for the system, right? Solution for the system. So actually it's the same thing, okay? It's the same thing. The intersection of those two straight lines, which means this point satisfies the two straight lines simultaneously. What does those two straight lines mean? Those two straight lines are the two linear equations, right? So of course those intersection, the x1, x2 values will satisfy those two equations simultaneously. So this intersection actually gives the solution for the 2 by 2 system, right? Now, in this way, if we can show the straight line of the second one, then we can find the solutions of this 2 by 2 linear system, right? I know it might be easy for some of you to solve this 2 by 2 system in a linear algebraic way, but we are trying to looking at it in a geometric way, okay, to interpret each linear equation as a straight line, okay, as a straight line. Now let's check. We just rewrite those two equations, okay, those two equations. Again, x2 equals minus x1 plus 2, right? How about the second equation? x2 equals minus x1 plus 1, right? So let's draw the graph. Okay, let's draw the graph. x1, O, x2. The first one it's the same, right? The first one is the same. Shift y equals minus x2 unit upward. So this is x2 equals minus x1 plus 2. Here is 2. Here is 2. How about the second? How about the second line? Let me use blue color. That will passing through 1, 1. Intercept on x and y are both 1. So this is x2 equals minus x1 plus 1. Do we have any intersection for those two straight lines? We don't have any intersection, right? Here is 1. Here is 1. Actually, for the first straight line, the slope is minus 1. And for the second straight line, the slope is the same, minus 1. They are parallel to each other, and they will not intersect, right? There is no intersection for those two parallel lines. So what does this mean? Do we have any solutions? If you check this simple 2 by 2 system, when x1 plus x2 equals 2, we cannot find the same value satisfy x1 plus x2 equals 1. It's easy to understand. Solution not existed, right? So for second one, solution not existed. Okay, solution not existed. So what does this in the graph? There is two straight lines are parallel to each other, no intersection, right? No intersection. How about number 3? Okay, how about number 3? If you multiply by minus 1 on the second equation, in the second equation, on the both sides, for the second equation, you multiply by minus 1 on both sides. It's the same, exactly the same as the first equation, right? So which means we only have one straight line, right? Two equations, that only means one. You only need to find the value x1 plus x2 equals 2. How many solutions do we have for this case? That means all the point on this straight line will be the solutions, right? All the point. So x2 equals minus x1 plus 2. We only have one straight line for this 2 by 2 linear system, right? For this 2 by 2 linear system. But we are going to have infinite number of solutions. any point you choose on this straight line that will satisfy x1 plus x2 equals 2, right? 2, 0, 0, 2, 1, 1, 1.5 plus 0.5. So what is the solution? Infinite number of solutions, okay? Infinite number of solutions for the 2 by 2 system in number 3. Infinite number of solutions. So 2 by 2 linear system is the special one, okay? Is the special one, and I mean we can check it in the plane, in the XOY plane, in the 2-dimension plane. And actually it's the same for the 3 by 3 system. The solution for 3 by 3 system, actually that is the intersection, okay? That is the intersection of the 3 straight line, okay? 3 straight line in the 3-dimension, okay? 3-dimension space, okay? It's not a plane, it's a 3-dimension space. So we can extend it to n by n system, okay? N by n system. For the last equation, number 3, last equation, those two are the same, so we only have one equation, x1 plus x2 equals 2. Then we are going to have infinite number of solutions which satisfy this equation, right? So that is the 2 by 2 system, okay? That is 2 by 2 system. And we understand that for the 2 by 2 system, each linear equation is a straight line in the 2-dimension plane, and the intersection of the straight line of 2 straight line gives the solution of this 2 by 2 linear system. If there is no intersection for the 2 straight line, that means the solution not existed. If we have only one straight line, those 2 linear system becomes one straight line. That means we are going to have infinite number of solutions. We will focus on the solutions later, okay? Discussion of the solutions later. Now let's move to the equivalent systems, okay? Equivalent systems. Considering the following 3 by 3 system, right? Those are 3 by 3 system. How can we know that? 3 equations, 3 variables, right? 3 variables. So 3 by 3 system, that will be A11 x1 plus A12 x2 plus A13. So I saw the 弹幕, okay? I saw the 弹幕. Some students ask any interval for the linear system. We are going to solve the linear system. Do you have any restriction? The solution should be all the real numbers. The solution we are going to solve for the linear system, they should be all the real numbers. So why there should be an interval? We are discussing linear system. We are going to solve the solutions from all the real numbers. So there is no interval. Linear algebra is a totally different subject from calculus, okay? From calculus. Calculus, we are talking about the function is defined on some domain, but those are the linear systems. They are linear equations. We are going to solve the variables, the unknowns, x1, x2 for the 2 by 2 system. So the solution can be all the real numbers. All the real numbers for number 3. All the real numbers x1 and x2 which satisfy this equation, then it's fine. Then that are called the solutions. So that's why I said infinite number of solutions. There is no interval. There is no interval restricted. How can we have intervals here? It's a linear system, okay? It's a linear system. We're going to solve the unknowns for all the real numbers, okay? For all the real numbers. Now let's continue here, the 3 by 3 systems. A21x1 plus A22x2 plus A23x3 equals B2. A31x1 plus A32x2 plus A33x3 equals B3. That is the standard 3 by 3 linear systems, right? We do have 3 equations, 3 variables, 3 unknowns, x1, x2, x3. And then all the aij's and bi's, they are given, they are real numbers. Okay, they are real numbers. We discussed the linear systems in the real numbers. Okay, real numbers. So comparing those two systems. Okay, for part A, let's solve it. Let's solve it for part A. It's pretty easy, right? Pretty easy. What is x2? x2 equals 3. That is pretty easy. And we do know that for A21, that is 0, right? You can take this one as 0 times x1, right? For the first 3 by 3 system, you can take this one as 0 times x1 plus 1 times x2 plus 3 times x3. Right? For the third equation, you can take it as 0 plus x1 plus 0 times x2 plus 2 times x3, right? Plus 2 times x3. So it's easy. x2 equals 3. How about x3? x3 equals 4 over 2, which is 2. Then let's go back to the first equation, right? Let's go back to the first equation. 3x1 plus x2, 2x2, x2 is 3, then minus x3, x3 is 2, equals minus 2, b1, right? b1 is minus 2. So what is my x1? This is 4 minus 2 minus 4. What is my x1? My x1 is minus 2. It's easy, right? So the solution for the 3 by 3 system in part A, that will be minus 2, 3, 2. We always write the solution for the linear system in this way. x1, x2, x3 in this order, okay? In this order. So x1 is minus 2, x2 is 3, x3 is 2, right? The solution is minus 2, 3, 2, which means the solution for the 3 unknowns that satisfy those 3 equations simultaneously, right? It's easy for part A, right? And then part B. How can we solve part B? Let's solve part B first, okay? So for x1, at least for the variable x1, you will notice that here is 3 minus 3. So if we do equation 1 plus equation 2, the x1, the coefficient for x1 becomes 0, right? Which means left part plus left part, right part plus right part. So let's do equation number 1 plus equation number 2. So for x1, that becomes 3 minus 3, right? And then for x2, the coefficient is 2 minus 1. And how about x3? Minus 1 plus 1, right? x3. And then the right side constant will be minus 2 plus 5. b1 plus b2, right? Left part plus left part, right side constant b1 plus b2. Then we have 0 times x1 plus x2. And for x3, it's also 0 equals 3. So what is my x2? My x2 equals 3, right? My x2 equals 3. And then for equation number 2 and equation number 3, we can do the same thing. Let number 2 plus number 3. So minus 3 plus 3. For x1, the coefficient will also become 0, right? Let's do it in this way, okay? Let's do it in this way. So For x1, that is minus 3 plus 3 x1. And then for x2, that is minus 1 plus 2 x2. And then for x3, that is 1 plus 1, right? The right side constant becomes b2 plus b3, which is 7, right? b2 plus b3. Then 0 times x1 plus x2 plus 2 x3 equals 7, right? Equals 7. So what is x3? Here we have already know x2 is 2. So that is 2 plus 2x3 equals 7. What is my x3? Any mistake? 7, 5. 2x3. Oh, here is 3, sorry. Here x2 is 3. Yes. So my x3 is 2, right? My x3 is 2. So I solved the x2 is 3, x3 is 2. Now we can go back to the first equation, right? Or any equation of one of those 3. Then we know x2 and x3, then we can solve x1. So 3x1 plus 2 times x2 is 3, minus x3 is 2 equals minus 2. What is my x1? My x1 will be minus 2 minus 4 over 3, which is minus 2. So what is the solution for part B? We still write x1, x2, x3. So the solution, okay, let me write here. The solution for this one is also minus 2, 3, x3 is 2. What is the solution for part A? Minus 2, 3, 2. You will notice that those are two different 3 by 3 systems, but they have the same solutions, right? They have the same solutions, which means exactly the same x1, x2, x3 values. So those two systems are called equivalent system, which means they share the same solution set. Okay, they share the same solution set. So definition, two systems of equations involving the same variables are said to be equivalent if they have the same solution set. Of course, they involve the same variables, right? The same variables. We do have 3 variables. We solve x1, x2, x3. Then we noticed that they have the same solution, okay? Equivalent system. Why we need these equivalent systems? If we have some 3 by 3 system like part B, and after a series of operations, I can convert it into part A. I can convert it into a simple, easy equivalent system. Then that will be nice to solve part A instead of part B, right? And then we know the solution for part A is the same for the solution of the system in part B, right? That's a purpose we discuss the equivalent system, and we will do this work later. Okay, later. How can we perform the operations? Yeah, I know it's time. Okay, let's take a break.